Hi YouTubers, Dave out in Western Pennsylvania, USA. We just completed a 75 cycle run of nickel plated felt. Please refer to my prior YouTube video where we ran the nickel plated felt under so-called dry circuit conditions. Dry meaning graphite, commercial material, not treated in any way with alcohol or any electrolyte or solvent. Run as is. That's in a prior run, dry circuit. In with a lithium ion 3.7 rechargeable cell. So we can bring the graphite up to 4.1 volts, discharge it to 3.0 volts, 750 milliamp charge, 750 milliamp discharge with a minute rest period. So we ran 75 cycles. We were checking the mass balance before and after the run. And we used these plastic cases that hold dental floss material. Pretty stable plastic. We ran an infrared. I have to identify it. It holds up very well. The company that manufactures the product will not tell me. They never got back to me to tell me the plastic, but it will not react with dimethylformamide. And it seems to be pretty good for bench scale sections of graphite. A couple of clips attached to the graphite in there. And you can find them in a craft store, for example, Walmart, stainless steel, and they're very convenient for attaching the leads. Well, in any event, after 75 runs, 75 cycles, holding up very well. The mass balance before the run and after, before the total mass was 7.273, and that's with 337 milligrams of choline, chloride, urea, deep-eutectic solvent with 5 to 7% mass of lithium tetrafluoroborate electrolyte. There's a piece of chromatography, paper chromatography. It works very well, a section where after we applied the electrolyte solution, we put the paper in and pressed it to get it into the graphite. That paper was 0.1118 grams, so not much mass added there. And after the run, the mass was 7.280 grams. Before, 7.273. So we picked up about 7 milligrams, and that could be something in the plastic, could be that a subtle change occurred. We did use two different balances, but that shouldn't matter. They're calibrated. But just a small but measurable difference before and after in terms of mass. We'll be uploading the values for in particular, the energies in milliwatt hours after cycles 5, 15, 25, 35, 40, 50, 60, 75, and it tends to stabilize. Once you get to about cycle number 44, approximately 44, it begins to stabilize. And here's a diagram of the last number of cycles. Ran for about 19 hours and a half. And you can see the parameter settings. And you can see some of the numbers up there for the capacity of charging under constant voltage with trickle current down to 200 milliamps. So constant voltage, charge, discharge, constant current, 750 milliamps. And it's holding up very well. So this is what it looks like. You can see the graphite sample. and we insert it right into the circuit with the negative. So it's right in the circuit with the lithium battery. And in other words, we're testing various deep-eutectic solvents with electrolytes and charging up to 4.1 volts and bringing it down to 3.0 volts to protect the lithium battery. And we're demonstrating that the E supercaps, now the ones with water, they're going to have a potential, you're going to stay about 1.1 volts because you don't want electrolysis of water occurring. With organic solvents like DMF or the carbonates, the carbonate esters, in industry they put them out at 2.7 volts. They're worried about flammability, leakage, explosions, fires, and rightfully so. Here's a typical commercial supercap we use, and about 2.7 volts. This has a capacitance of 100 farads, which is very good for estimating capacitance after runs. And we insert that right into the circuit, and we're demonstrating that we can bring these up to 4.1 volts. Now, of course, 100 cycles is one thing, 1,000,000 is another. But it's a way to look for any flaws right from the get-go and use small amounts. Some of these deep-eutectic solvents and ionic liquids are conductive, but they're expensive as hell. So this is a way to test out a DES or ionic liquid solution with electrolyte. And I can tell you, lithium bromide, anhydrous lithium bromide dissolves in this choline chloride urea, 1:4 mole ratio, which is very interesting. We haven't run it yet. We've been using lithium tetrafluoroborate. But in any event, I will put the website down. I'll be retiring from my university. I'll be retiring in June after 41 years with our campus, but I'll be continuing research in this area. And at the website, which I'll put the link down, I'll start uploading the data for our runs and dry and wet. So this is a wet circuit because of the electrolyte and DES. So far, so good. So we'll keep you posted. And thank you for watching. And if you didn't see our other video, we use an electronic load device, ZKE Tech. They're excellent for the product, for the cost. You find them on Amazon, eBay maybe. Make sure you get the model A10H. The A20H does not do cycles, and you surely would want to use cycles. You can see the cycle test. You can also do auto tests, which I'll use with capacitors. I'll actually put a capacitor, a commercial capacitor like the one I showed you, with a test graphite, put them in the same circuit. I want to see what happens to the capacitance values with the graphite, with its electrolyte, and DES in the circuit with it. So a lot of experiments to do. And I thank you for watching. Bye for now.